Hey guys, so after a long time, the Azure guys back with some more excitement series. So this time we're gonna talk about AKS from scratch. So I took a break before making many videos. I've thought to make something useful because basically we require to always make solutions around the challenges which we face day to day life and executing your particular tasks. So AKS is a booming concept which has come up. So AKS is nothing but Azure Kubernetes Service. So what does Azure Kubernetes Service does? So and how it is different from different the Kubernetes service from the Google itself. Okay, so in this particular series we're gonna talk a lot about AKS, and we'll have a lot of hands-on on integration, like if your organization is selecting or picking up a solution for to build AKS or Azure Kubernetes Service. Why you would require Azure Kubernetes Service? Because I would require because I have applications which are running on a virtual machine or which are running on on-premise, and I want to make it more scalable and more cloud agnostic. Okay, so in order to make cloud agnostic, you need to cut out the bare metal dependency which your application would be having. But it can be your application can only run on Windows, your application can only run on a Linux machine, Ubuntu, Fedora, or any other machines, or which has very tightly coupled, or even it can be run on VMware like that. So the Kubernetes came like a few years back, and it had made a lot of impact because the ease of deploying applications within seconds, and spinning of applications, and even you can say scaling of applications is also so easy. So my this particular AKS series will have many of the things, like so it will be, the series would be constituting of at least 8 videos as of now, and each of these videos will try to get into some objectives which would clear many of the Kubernetes terminologies which are a bit hard to understand, or the Kubernetes or the application. How does actually you can deploy an application into the Kubernetes cluster? What is replica? What are namespaces? What are pods? What are cluster? What exactly is the AKS cluster? And there are a lot more things about it, and how exactly or why did Microsoft had gone to get this particular product on Azure platform. So there are a lot of things which comes hand in hand with Kubernetes, and which other particular services like the Docker Swarm, which was initially, I can say, is a pre concept of Kubernetes, but it couldn't click, and that's a product from Microsoft. But why did Kubernetes has clicked so good? So you will understand the with the entire series going on, we'll be having a lot of videos, not these eight videos. So let's pick up what particular videos or what particular concepts we're gonna cover. So the first video would in the series which is today, will be covering up understanding Azure Kubernetes Service, and how exactly it differs from the version that Google publishes, the Kubernetes. And we'll see also the limitations of using AKS, not Kubernetes, from the Google, and advantages, obviously. And then we will go towards the second video would cover spinning AKS cluster, basically a non-RBAC enabled AKS cluster. We're gonna create manually with and understand all the parameters which we will be keying into the portal. So we will go and we create resource, and we select something as Kubernetes service, and whatever these key parameters which you can see, we'll be trying to explain. And after that, basically keep a note, this would be non-RBAC cluster, which means a non-role based access control particular cluster which would not work, or the cluster users cannot log in or cannot take advantage of RBAC feature which is provided by Azure Active Directory. But yes, we will discuss upon few terminologies: clusters, nodes, namespaces, pods, containers, applications, how do you deploy into containers, and we will define how what ingress controller and ingresses work. And the third video would be having more of troubleshooting issues with the cluster. So if your pod is not running, if your pod collapses, and like if you deploy something and your pod goes into the crash loop back, and there are a lot of parameters which are pasted daily, day-to-day basis by many of the engineers. So, and we will try to debug with the default monitoring which are given by Azure. Like if you take an example, the Azure Monitor, the log analytics or the OMS enabled on it, or we have few features of application insights which have been enabled on top of it, but it won't be visible directly to you. So those things we're gonna discuss on video 3, and video 4 would be more of spinning an AKS cluster on Azure portal, but via the CLI, which means we're gonna use our Azure Cloud Shell to deploy us a cluster, but this would be an RBAC enabled cluster. So the RBAC enabled clusters would require a lot of changes. You need AD apps, server app, AD app, and client AD app, and you would need certain API permissions, and in order to allow API permissions you would require admin grants. Okay, and so this particular RBAC enabled cluster would boost you with a lot of different features which you're gonna have. And for your kind information, so CLI provides a lot of different features which you can enable, which you can't actually do with the portal in the manual way right now, as of today on 28th March 2020. And going forward we will be looking onto the video 5. So it would say about more interacting with RBAC enable AKS cluster. There are few of the differences which you will find with the normal without a non-RBAC, you can say as a non-RBAC enable clusters and RBAC enable clusters, how they differ. You will be coming to know. We'll be using a lot of kubectl commands for provisioning, deprovisioning pods, spinning up of containers, draining nodes, and we'll understand replica sets, how exactly they're going to work. Probably we will go more into availability zones and a lot of different concepts. And the video 6 will have the monitoring solutions. Since the native default monitoring solutions which are provided by Azure are not enough, if you are going for your AKS clusters, which is multi-tenant support, which means you will be using a single cluster, but you'll be sharing with various different customers, various different applications. So when you do that, you need to take care of data isolation. You do not mix up a customer's data with another customer's data, or you do not reveal the secrets or the certificates which have been installed for one particular customer with another particular customer, because at the end of the day, when you say as a single cluster, so the metal which is underneath, the drives can be accessed by the other particular users in the cluster, right? So how we gonna tackle, or how we gonna build a system, a multi-tenant AKS cluster? So, and this is monitoring solutions, we're gonna talk about it. And like when we build multi-tenant systems, obviously the monitoring solutions also need to be very impactive, or should get the analysis of the application specific, customer specific data, or it should only monitor the customer specific data, not others. So for that only we have integration. I've integrated Prometheus, which is like Prometheus is a different installation, but in order to make our life easy, I just made it as a container image, and I use that image and then I spin up on the same cluster where we have this AKS cluster be running. And we will use a Grafana, which produces beautiful charts, and you'll be very interested. And then like it would give very application or customer specific data which you can also use to troubleshoot the issues with your cluster or the pods usage or the namespace usage or the containers usage. And going forward, like we will go on the video 7, which will have integration of Grafana, the dashboards with Azure Active Directory. I'll show this how it gonna look exactly in the next portion. And video 8 would be having the cost is main for every particular tenant admins or stakeholders, because they need to calculate. And when you go with a multi-tenant AKS clusters, you need to calculate per individual or per customer calculations, how much they are using, how much the load they are putting on the cluster. Basing upon then you would be calculating the cost and producing a bill for them. So for that, we'll be integrating with KubeCost as a basic preliminary thing. And then we will, while we make all of these particular POCs and hands-on, we'll be putting up more of the videos going forward. So let's go and try to understand what exactly is Azure Kubernetes Service. So you must be knowing about Kubernetes. So Kubernetes provides, what you can do with Kubernetes is like you have an application, then you can take your application and you containerize it or make an image, make a Docker image out of it, and then you deploy onto any of the services, like you can push onto the Docker Swarm, or you can have something called as Azure Kubernetes Service or Kubernetes directly. Okay, so what happens, so when you use a Kubernetes AKS Kubernetes Service, so this is a plane, this is a particular portion which AKS, I can say, which would have your pods, and which will have a component like Kubernetes API. Okay, and then we have certain components which dumps your particular logs into or interacts with the ARM, with the AJEC. And what happens, when you spin up an AKS cluster, it provisions few things, like the cluster can be provisioned with the help of nodes, like the cluster can have nodes, or the cluster can have virtual machine scale sets. So the virtual machine scale sets will internally have nodes. Okay, and nodes, when I say it's and the background is just virtual machines. So the virtual machines are the nodes. So you can see the AKS cluster will have nodes. Nodes are like virtual machines. It can be under VMSs. So VMSs advantages are different, so which we're going to speak about it. And the nodes will have something called as pods, and the pods are categorized or grouped under namespaces. So when we talk many things about Kubernetes, we have a logical grouping in Kubernetes service like namespaces. So and namespaces are sort of resource groups in Azure, and you can take the advantage of the namespaces in order to segregate your resources, segregate your pods, segregate whatever the resources you're going to spin on that particular pods. And with respect to the pods, you can segregate the ingresses. So basically the ingresses are nothing, because if you have an AKS cluster or a single cluster, the single cluster may be having a lot of namespaces, and a lot of namespaces may have pods, and each pod will be having containers running. So in the container you have your application. Okay, so how does that traffic, the user sitting outside the world would know exactly or rerouted exactly into the application which is running inside the container, which is running inside the pod, and which is running inside a specific cluster. So this is where you have the concept of ingress controller, which actually maps with your DNS. DNS mapping, like if you use a certificate or you need to do a DNS mapping, where in the DNS for the DNS providers like GoDaddy or any of the, or you can use Azure DNS itself to map your particular service which is running inside your container, which is inside a pod, exposed outside to the world. Okay, so in order to make it more secure, you would not be, we don't suggest to create your own public IP to expose outside to the world. Rather, use an app gateway for your enterprise, and tag your particular your particular IPs in the app gateway, and then tag that particular IP intent externally to the DNS provider. So whenever you use a type something called as xyz dot my Kubernetes service, it would result back to the app gateway, and app gateway knows where exactly your application is sitting. Okay, and then it would forward that particular traffic to here. And then if you use SSL or HTTPS sort of traffic, then you can cut off the HTTPS traffic and just reroute your HTTP calls to your very particular to your container. So that you can, like, there's a concept something called as SSL termination, which you can use. And you can also mention, like, the traffic, if it is coming at the ingress controller, you can mention how much data of the, you would try to allow, or you would allow to come inside your application. Because if you're sharing your cluster in that cases, you can split the request, say the applications to split the request into chunks and allow only a specific size of data to come in. And you can mention HTTP request forwarders, everything, and those things will come up. You will come to know slowly. And this is how, the request. So if I want to if as an admin, AKS admin, if I want to communicate with kubectl commands, so the kubectl commands always interact with Kubernetes API. Okay, it do not interact with pods or containers directly, but it would always delegate your command, the kubectl command, like, you would say in kubectl command, like, spin up pods. So the API server inside the AKS would listen to you first, and you can interact with cloud shell, you can interact with bash or anything. But for that, your admin, the cluster admin, should give you a kubeconfig file in order to interact with the specific cluster. So what does a kubeconfig file have? So the kubeconfig file have very specific information about, which particular cluster you have access to, and which particular resource it is, which particular resource group or subscription it is. And you can, that gives you context, or set up the context to start a session with your Kubernetes API server. So that's one way where admins or the developers would interact with the cluster. But yes, if once you have applications installed on your AKS cluster, so the traffic need to come, it comes via a different way. It comes from the app gateway or any of the public IPs you expose with an external load balancer. So when you do that, and the traffics, the applications are exposed via this way. So your external users will not come, the requests will not come at any point with the API server. Rather, the admin, the developers will have, the traffics would come from the API server, but the external traffic comes always from the outside world, directly to the pods and to the containers, not via the API server. And if you go the same thing, like the Kubernetes have something called as masters and the nodes concept. So in Azure Kubernetes Service, if we speak about the differences, how it differs from the Kubernetes service from the Google. So the Kubernetes master, which we have on Azure Kubernetes Service, is maintained by Azure. There are a few of the things which they want to make in control, and it's not on the Kubernetes master how frequently or how load it's taking up. It do not matters, because Azure gives as a service to you, and it's not billable. The only billable things with the AKS cluster is your nodes. So what sort of, or what size of nodes and you are running would be the only particular parameter which would produce you a lot of billing. Okay, so if you spin up a node with basic size or the required size only, that would be great. You can save a lot of costs. And for those for how to cut costs, this particular particular costs and other concerns, we have something called as the cube cost and other monitoring solutions, or cost monitoring solutions, which we have, which would be discussing in video 7 and 8, which would really help you in cutting out a lot of your costs. And so the Kubernetes master, which we're talking about, so the developer, admins, or the operators would interact with the API server, and the API server will have something called as controller manager, scheduler, and it would have an HCD storage, so where the context about the developer information, who is interacting with the cluster, would be stored in here for future purposes, like like setting up the session, frequent sessions, and other stuff. And this particular portion is called as the control plane, and because you do a lot of control of your nodes and pods via this particular control plane. And the users directly, as I said, they come with the app gateway or the external load balancers. So this is how the users are coming to your queue proxy, and the queue proxy or the ingress proxy, or the ingress is what you define. They would come through that. So ingresses would also tackle with your queue proxy. The requests which would come to the queue proxy, and then would be redirected to the pods with the use of ingresses. So in our series, we would be using engines, which is widely used to configure our ingress controllers and ingresses and reroute the traffic. If we go ahead and try to understand a bit more about the control plane, and so this is the control plane, as I said, like Azure manages that particular control plane. It manages our HCD, the HCD storage, the API server, and the scheduler. If we are defining like the nodes when they should start and stop, so that would be managed by Azure, and the controller manager is managed by Azure. You just need to interact with the kubectl commands. So the customer, what they manage is the nodes, so the size of the nodes, the number of nodes, the number of replica of nodes they want to scale up, scale down. You can set auto scale on top of it if you're using something called as VMSs. Okay, and your customer